Before we start, I'm going to put a real big disclaimer right up front. Do not do anything I talk about in this video. All of the machines I'm dealing with here, either I own them or I have full permission from the person who owns them. So absolutely do not copy anything I'm doing here unless you own the machines or have permission.
Absolutely. Don't try this at home.
Do not try this at home.
No,
absolutely.
Only try this at home.
Oh, yeah, that's a very good point. Try this at home, but not anywhere else at all. What we're going to look at today is, I guess we could call it how to hack out of a computer. You've got a few videos about things like SQL injection and how to get into computers. But now let's imagine you're on a train, in an airport, or on some network where the administrator is not giving you full access. So you go to watch your favorite Computerphile video on YouTube and the network's not letting you into YouTube. What could you do about that? Let's introduce the concepts that we need to think about. So let's get the OHP up. Okay, so let's start and think about some kind of basic setup. So here is a crude drawing of a laptop, and you're connected into a network here. You want to access the internet over here, but here is our enemy for today, the firewall. All right, so there, your only way out of the network is via this firewall, and the system administrator can put various restrictions on there. So let's imagine if you're on a train in the UK, the bandwidth is horrible because it's got to go via cell phone masts and it's changing about what it's connected to. So they typically, on a train in the UK, they're not going to allow you to watch YouTube because that would take up the entire bandwidth for the entire train. All right? So that firewall will be set to block that site. And so this will have a bunch of blocking rules. And that can be a variety of things. We might say we'll block a particular site. We might say we'll block a particular port. Remember this abstraction of a port, it's what transmission control protocol uses to determine where connections between two computers, which application we connect to. So HTTP web is on one port, secure web HTTPS is on another port, SSH, which you use to connect into a computer, on still another port. And those rules might block a particular site, or they might block a particular service. So they might say you can't connect to your email server, or they might say you can't connect to SSH, something like that. Port 80 is default web browsing, and port 443 is default secure web browsing. Nowadays, almost everything is over HTTPS, and if you see something running HTTP, that's pretty old-fashioned. So for the purposes of this demo, I've set up a machine belonging to a friend of mine. So this is going to be living somewhere on the internet, and this is our kind of target machine here. So it's a machine called Twisted. I've set up a little test web page on it. Well, not even a web page. Now the curl command is just a text way of browsing the web. It's just a text way of grabbing a web page. And this is just saying, grab from this machine, Twisted, the page saying test. And we get back this, hello Computerphile viewers, this is a test to show that we can access this file. Right? All pretty simple. Now, let's imagine we are the system administrator, and we're going to start messing about with the firewall. So I'm using Linux. This will work more or less the same on a Macintosh. The firewalls are pretty much the same the world over. It's only the syntax were different. So this one is UFW. I think it's Ultimate Firewall. Very exciting name. Let's have a look at what it's doing so far. So, whoops, mistyping the password. Because this is my home machine, and there's no way into this machine anyway. It's denying 3 different things, all related to mail services, allowing anything else. So what if we say let's block off that website we wanted to go to. So I can very simply add in a rule to block some ports off. I'm going to deny outgoing traffic. That's the IP address of the server I'm trying to contact. And I block off HTTPS, and I block off HTTP. And now if we look at our firewall status, it's denying to that IP address, it's denying outgoing traffic to HTTP port 80 and HTTPS port 443. So now, in theory, we can't get any web traffic through to that website. So let's try again our command to get that web page. We're trying to get it, and it's timed out. I hope I've convinced you that me, the nasty system administrator, has blocked myself from accessing that website. The question is, how can we get around that? There's quite a few ways. One of them is to use SSH. Now, SSH is the command we use. The normal use of SSH is just to log into a machine. So if I do SSH richard@richardclegg.org, that will simply connect me to my remote server. Yeah? That's the normal use of it. It sets up a cryptographically secure connection from one machine to another. So I've connected from my home machine, Barkentine, to my server, richardclegg.org.
That's how you send your files to me as well, isn't it?
That is actually, yes. SSH and SCP, that's how I transferred a video over to Sean for him to do the magic and try and make me look good and edit out all the bits where I've gone But there's lots and lots of things you can do with this SSH. It's a generic way. Once you've got that SSH connection open, we can do a few things with that. So here, I'm going to add in a few little things to that command. So I'm going to tell it -f, do that in the background. N, we don't want it to execute any particular command. And this one, this -D1080. It's going to take a little bit of explaining, but what that says is, to the SSH command, it says, listen on the local computer on port 1080, and any traffic you now get to port 1080, I want you to push that traffic down the tunnel, down the SSH, and have it come out the other end. So now what we've achieved is anything that I send to port 1080 on my local machine will go down this tunnel and come out at the other end on my remote server on richardclegg.org. Yeah? What we've kind of done here is we've built, let's have richardclegg.org on there. I'll just put Richard for short. And what we've done is we've built a little SSH tunnel, and that's listening on port 1080. So anything I push to port 1080 on my local machine, that's going to spit out on this machine here. Okay, so what's the point of that? We can use that as a proxy. We can pretend that that is our web service. So for example, if I do this, that says to the curl command, so I've got this SOX5, it's what we call a SOX proxy. It's saying there's a raw socket, there's a raw port that we can push data down, and it will act as if it's a connection. It will act as if it's a tunnel into this machine. So now I'm saying, instead of going directly to this machine, I want you to go via that SOX proxy. And we can set our whole machine to use this. We can go into settings, we can set up a proxy, and we can say 127.0.0.1 port 1080 is going to be a proxy host. So now if I do this, my web browser is also using that proxy host, and my web browser is going via this SSH tunnel to access the site. That's the very simplest way we could get around this problem. If you're on a Macintosh, you can do something similar. If you're on Windows, you can use a program called Putty to do something very similar. There's actually a really cute little problem with this. And if you do this, you find your connection becomes incredibly quirky. Your connection becomes really unreliable. And there's a nice little reason why that is. Because what we're doing is, this SSH tunnel uses TCP. Yeah? Mm-hmm. So TCP is a lossless protocol. TCP ensures that packets that are lost are retransmitted. Okay? And that's fine, that's TCP's job. But we're doing a really strange thing here with the SOX proxy, because what we're doing is we're now inserting a second TCP session, but it's going over this tunnel.
So TCP over TCP.
TCP over TCP. So the TCP is being carried via the SSH tunnel, which is also TCP. Things in this tunnel now can't be lost. Yeah, because the tunnel itself is providing reliability. Now you might think, well, that sounds great, Richard. We don't want things to be lost.
Double reliability.
Yeah, we've got double. It must be twice as good. Super reliable, right? The problem is that TCP actually relies on loss. TCP doesn't work well without loss because TCP uses loss to tell when it's too congested. The only way that TCP knows that a network is congested is when packets are lost. So there's another thing we can do. So I'll just kill off my TCP tunnel. Now instead there's a really nice program called S-Shuttle, which wraps up all of this tunneling nonsense into one quite convenient program. So it's brilliant. It takes care of the TCP properly, so we're not doing that horrible TCP over TCP thing, which should offend anyone who's studied congestion control. You should be really horrified by TCP over TCP. So S-Shuttle, really simple command here. This is saying S-Shuttle to the remote server richardclegg.org. Any traffic on this machine destined for any of this particular address block is going to go through that tunnel. And this will just take care, on a Linux machine, it will take care of any traffic destined for anything beginning 178.250.76 as an IP address, and it will take care of ensuring it goes through that tunnel. So we've got to wait a bit for that to set up, and then just do an SSH in, and I can connect in, even though port 22 is blocked, and the only access I have is a proxy server, we can get in like that. If you wanted the one line of how to do it, if you were on a place where it allowed, where you had access to SSH and you had your own server, that S-Shuttle is a brilliant way of doing it. If you're the system administrator, you might think, well, I've still got a few things I can play with here, because you're the system administrator, you've got a lot of power in this system. One thing we could do is block off SSH. Yeah, you could say, well, hold on, if you're going to use SSH for shenanigans, let's make sure you can't do that. Again, there's a real simple response to that. So if you're running your own server, you can say, fine, you've blocked off SSH. What I'm going to do is I'm going to make my SSH work on another server. So here, we're just telling this server, this is the Richard Clegg server, and we're just saying to it, make port 444 act as my SSH server. We added that rule, and now we can SSH to port, actually we probably can't because I probably haven't opened port 444, Okay, so we fed in a gap in the firewall 444. So that's a server I control. And now we can run that SSH and we can run it across port 444. And even if the system administrator blocks off port 22, we can still get in. Now, if you are actually wanting to make a site, if you actually wanted to make a network really secure, you don't have default open ports. You close down everything. Yeah? And if you want to make a site really secure, you don't allow people to directly access port 80. You don't allow open access to port 80 anyway. You use a web proxy. Let me draw out that more secure system for you. In our hypothetical scenario, this Richard Clegg machine, this is our web proxy. Our system administrator is really locking things down and they're going to block everything. There's one or two things you have to allow, and if you want people to be able to browse the web, you need to allow some access there. So what you need to allow is access to the web proxy. The only thing that we're going to allow the person to get to is the web proxy, and that web proxy then you can say, yeah, and that web proxy is only going to carry certain sites. It's only going to carry our allowed list of sites. Okay, so can we now get to our target machine up here, the twisted machine? This is a little bit more challenging. I mean, to be honest, actually, when I was messing about trying to do this, it took me quite a while to get this one working. The basic thing we can do here is use the web proxy to bounce our SSH. Yeah?
Yeah.
So, I'm not going to explain too much about this, but I will on the way. I just want to explain one command. This command is so useful in networking. It's not as well known as it should be, and this Netcat command is gorgeous to work with. It's so useful for testing and making sure that machines are working, and it's just a way of generically allowing you to listen on a port and wait for a connection and send traffic to this port. So it works in pairs. So I'll open up another gap in my firewall. I am going to shut these after the video. So that's added a port 2222 to listen on. And this says listen on 2222. And then from my home machine, so I type hello there, and it comes up. That may not seem like much, but that is so useful for testing your network, for making sure that those particular ports are open. But also this is now, it's become a generic way. So I could, for example, I could look at my web server and see what happens if I say hello to a web server. And it said that hello is a bad request because that's not a language that web servers speak. Yeah?
We need to get working on that, I think. You know.
Yeah. I'm not sure. I think probably sticking with HTTP is good for the old web server there. That's a bit of an aside, but I think people who don't know the Netcat command, they're really missing out because it's really, really a very, very useful command. So what I've done is I've made this richardclegg.org machine act as a web proxy. I have to do a little cheat here because I don't have root access on that twisted machine. So what I'm going to do is tell my proxy server whenever something exits on port 443, I'm going to map it back to port 22. So that is how this command looks here. And this is saying anything going to this twisted machine is going to be routed to port 22. This proxy command we use SSH, and we tell it to use a proxy via the nc command, via the richardclegg.org proxy. So this richardclegg.org 3128 is a proxy server listening on 3128. And if we do that, we can now get our traffic through the proxy and into Toybox. or we're trying to make an SSH connection, but on port 443. It's coming over here, and there's a little bit of a cheat here where I'm going to map that port 443 back to a port 22, which is the correct port for SSH, and it's going to arrive here at the SSH daemon, and we can respond, and we've got our SSH tunnel set up again. So even though the system administrator only allowed access to the authorized web tunnel, we were still able to get an SSH connection through and do all that tunneling. There's some really weird and wonderful varieties of this tunneling you can do. So we've talked before about a ping command, and the ping command was the command that let us send out a test to see if a server's working. And we can actually add traffic into that ping command and use that to send our tunneling. So we can add a little bit of informational messages onto the ping and use that to transmit information. But my very favorite one of this is lovely, is tunneling over DNS, domain name service. So this is a really interesting way of tunneling data. So domain name service's job is to say, if I tell you there is a machine called Computerphile.org, domain name service is the part of the system that converts that to an internet protocol address. Yeah. If you're the system administrator of Computerphile.org and you want a little extra way to get around networks, you can subvert that domain name service system. So it's your system that's ultimately responsible for returning the correct IP address for Computerphile.org. Now, what you can do is you could also have Sean.computerphile.org or mynewserver.computerphile.org or data I want to transmit.computerphile.org. And what's going to happen is the DNS system will eventually pass that request data I want to transmit.computerphile.org. That will eventually get to the DNS router you're using, and now you've got that data from the system. So you've established a path where you can transmit data, even if the only thing the system administrator is allowing is domain name service, and you need domain name service. So there's a system called Iodine that will allow you to tunnel these things over DNS. I've not tried it myself because it takes quite a bit of setup, but it's a really cute idea. I was intrigued by the level of ingenuity that went into that one.
So we now know how to tunnel our way out.
We now know how to tunnel our way out. In a variety of circumstances, we now know how to tunnel our way out of a network. But let me convince you why this is a terrible idea. So, okay, if you're on a train at an airport, you might get away with it. You're violating their terms of service. But if you're doing this in a place where the system administrator has locked things down well enough that the only way to get out of the system is through a web proxy, and they are only allowing you to access some sites, there are probably an awful lot of alarms and tripwires. They're probably monitoring that system very closely. So I spoke to a few friends who do web security stuff in the real world, which I certainly don't do. I'm an academic. And they said, yeah, Richard, but we would catch those people really quickly. Because if you think about a web proxy, what you typically do to a web proxy, you send it a command, please give me this website, it sends you the website back. What I'm doing in abusing that web proxy, I'm setting up a long-lived connection that will be there for many, many minutes or even hours. That's instantly suspicious. All right? So instead of this connection being there and gone, that connection is lasting hours. If a company is really serious about security, they've got proper endpoint monitors on those computers, and in any case, they're probably not going to let you install arbitrary software like this S-Shuttle on your computer anyway. Well, the other thing my friend said to me, and it's quite compelling reason, is he said, if you're on my system trying to hack your way out, maybe you'll be lucky some days. Maybe you'll be lucky once or twice, but if you're not going to be caught, you have to be lucky every single time. And I only have to be lucky once to catch you. And to me, that's a very compelling argument for not doing any of this.
Values are kind of the same. I mean, they're pretty close. That's a little bit darker, perhaps because the blue's a bit stronger.
Considering you've done that without actually measuring anything.
Yeah, I mean,
once that starts to happen, the traffic's just going to carry on going round in that loop. You've got a big problem.